Hello all, welcome back. In this session, we are going to discuss about entropy and Gini index method. And in addition to that, we are going to see what is meant by purity node and information gain. Credits to NPTEL videos, online resources, and many more. So, what is meant by purity node? So, purity node says about at a particular node how much pure the class is or how much pure the data set is. The objective of Gini and entropy method is to minimize the impurity, randomness or variance as much as possible. So there are various measures of measuring the impurity of a particular node. In this method, we are going to use only two, entropy and Gini. So consider there is a basket. It's a mixture of red and yellow balls. So pure node, it contains only one type of class always. So after splitting, the data group should be very pure. For example, in this case, the basket A contains 4 red balls, so it is called as very pure. And basket B contains mixed balls, red balls 2 and yellow balls 2. So we may call it as it's a pure. We can't say it is a pure node. We can call it as a mixed node. So algorithm always prefers a pure basket, right? Fine. Node purity means how mixed or pure the data is. For example, in this case, in basket 1, the basket is completely pure. In basket 2, it is mixed. So decision tree uses two methods, entropy or Gini, to measure this impurity. Now we are going to get into what is meant by entropy. So consider there is a basket. It contains 5 balls, 5 red balls and 5 yellow balls. So entropy measures how uncertain or randomness we are in predicting whether the next ball is red or yellow. Is to predict whether the next ball is red or yellow. So entropy is a measure of, in other words, we call it as entropy is a measure of randomness. So if you have high entropy, the data is very mixed. If you have low entropy, it is more pure data. If entropy is 0, that is the data set is completely pure. So always prefer lower entropy. So entropy is always a positive value or non-negative value. The equation to use for entropy is minus sum of p log 2 into p, where p is nothing but probability of each particular class. You can consider an example. How many members ate today is 7 and members who doesn't ate today is 2. How to calculate the entropy? The total entropy of this particular case is 0.76. How it 0.76 comes? The entropy of individual class of yes is 7 by 9 and no is 2 by 9. So answer is 0.78, 0.22. So entropy formula is minus class 1 7 by 9 log 2 of 7 by 9 plus second class, it is 2 by 9 into log 2 of 2 by 9. So answer is 0.76. This 0.76 depicts the total entropy of the data set before split of particular data. We have, in this case, we doesn't split any data. It's only single data. In other words, we can say 0.76 depicts that the event is somewhat random. So suppose if we are getting as 0.5, the entropy would be around 1, right? So if all the cases are yes, out of 9, if all the persons have 8 today is yes is 9 means the entropy would be around 0. So the mean information gain of that particular case is 100%. Now I introduce a new term called information gain. What is meant by information gain? The information gain is nothing but it's a decrease in entropy at a particular node. Information gain of T of x, which is equal to entropy of T minus entropy of T given x. For less entropy, the information gain will be high. Both are inversely proportional. Entropy and information gain are inversely proportional. To construct the decision tree, the features with high information gain is chosen. The information gain is always a positive value, it's a non-negative value, right? Fine. You can see an example for information gain using an entropy. Consider a basket that is before split, it contains 5 red balls and 5 yellow balls. The total balls is 10. The probability of red ball is 5 by 10, which is equal to 0.5. Probability of yellow ball is again 5 by 10, which is 0.5. Entropy formula minus sum of P log 2 into P. If you can substitute the value in this case and the total entropy, you will get it as 1. That 1 indicates the basket is highly mixed. Now we are going to split the basket into two smaller baskets, basket A and basket B. Basket A contains 4 red balls and 1 yellow balls. What about basket B? Basket B contains 1 red ball and 4 yellow balls. Now our task is to find the entropy of basket A and basket B and find the total entropy as well as information gain. That's our main objective. And entropy of basket A is given by 4 red ball is there, 4 divided by total ball is 5, so value is 0.8, and probability of yellow ball is 1, the total ball is 5, which is equal to 0.2. Entropy of basket A is 0.72. What about probability entropy of basket B? Same way, proceed with the same steps and you will get entropy of basket B as 0.72 again. So the weighted entropy of the particular after split is given by the weight in each basket is 5 total 5 balls out of 10 balls. So 0.5 is the weight. So entropy after is given by 0.5 into entropy A plus 0.5 into entropy B. So total entropy after, which is given by 0.72. So information gain is nothing but entropy before minus entropy after. The entropy before is given as 1 and entropy after is given as 0.72. So the total information gain is 0.28. So information gain is very less in this particular case. So it says the data is, our class is purely mixed. So now we are getting into Gini index. Gini measures how impure or mixed the bucket is. And the lower value of Gini says you will get higher the homogeneity, same as that of entropy method. So Gini, the formula is 1 minus sum of C equal to 1 to n PC the whole square, where PC says it's a probability of occurrence of the class. For samples belonging to one particular class, the Gini index is always 0, right? And for equally distributed, the Gini index will be around 0.5. So that is, it is mixed data, right? It's impure data. We can consider this example. The people those who ate today is 7 and no is 3. Out of this 7, 3 people ate today is veg and 4 people ate today is non-veg. And under veg category, the people those who doesn't eat today is 1 and non-veg category, the doesn't eat today is 2. So the people comes under veg is 4 and non-veg is 6, right? Now we are going to calculate for Gini index for subnode veg and non-veg. The Gini index for subnode with veg is 0.625 and for non-veg is 0.55. The weighted Gini for food after split may get it as 0.4. That is how the 0.4 comes. 4 divided by total value is 10. It is 0.4 into 0.625 plus 0.6 into 0.55. That gives you 0.58. So total Gini index is 1 minus 0.58, which gives you 0.42. It is approximately equivalent to 0.5. It says the data is impure, right? So information gain is same as that of your entropy method. In information gain of T of x, which is equal to Gini index of T minus Gini index of T given x. So this chart says the comparison chart, a difference chart between entropy and Gini index. Entropy measures the uncertainty of the data, but Gini index measures the impurity. And our goal in entropy is to reduce the uncertainty after split, whereas in Gini it is reduce the impurity after split. So entropy method is used in iterative dichotomizer 3 as well as in C 4.5 algorithm, where Gini index is used in classification and regression tree algorithm. In short, we call it as CAT algorithm. And here is the task for you people. For this particular case study, the people those who played kabaddi today is 9 and the people those who doesn't play kabaddi is 5. So I want you people to calculate the entropy and give your answer in comment box. Thank you.